Now I want to look at the reflective properties of a parabola. So I want to show you a quick animation online first of all for this. And if I can scoot this down. Okay, so what we see here are parallel rays coming into and hitting off of the edges of a parabola. And notice that all those rays all go to the same point, the focus. Here's another one where the parabola is a little wider. Now this may remind you of a satellite dish. All these different rays could be radio or television signals, sound or whatever, coming in, and they all reflect off to the focus where the receiver would be located. Or it might remind you of some kind of a reflector with light. So there'd be a light at the focus. Perhaps this would be the reflecting surface, the back of a traditional non-LED flashlight or a headlight of a car. And the light source would be located here. All the beams would go out from the light source, reflect off the back of this curved surface, and create a parallel beam of light going out. So this is, knowing how to locate the focus on a parabola is actually a very useful thing to know if you're doing anything with physics. Okay, so let's go back then and figure out how that is related to the equation of the parabola. So first of all, the reflecting property. Parallel beams all going into the parabola all reflect to the focus and vice versa. Now, how do we locate the focus? Well, you see two equations, y equals 1 over 4p x squared or x equals 1 over 4p y squared. You'll notice that 1 over 4p is in the same spot where we had our coefficient, which we called a. So a is equal to 1 over 4p, that coefficient in front of the squared variable. P is the distance from the vertex to the focus, and 4p is the width of the parabola at the focus. So let's look at an equation where a is equal to 1/12. A is 1/12, so that means 1 over 4p is equal to 1/12, which means 4p is 12 and p is 3. So that means the distance from the vertex to the focus, so here's the vertex, the focus is always directly above in the middle of the curve. So if we go straight up 3 units, we have located here the focus. That means anything that any beams that travel into here would reflect to the focus. No matter where they hit from, they would direct to the focus. And I'm going to erase those just because I need to draw some other things on here, but I just wanted to remind you of that reflecting property that we just looked at. Okay, so the other piece that it says is 4p is the width of the parabola at the focus. So that means if I were to draw a line through the focus perpendicular to that line from the vertex to the focus, this length is 4p. 4p, or 12 units long, from here to here. So this is +6, and this is +6 in this direction. Okay, so, or we could see it +6 and -6, but anyway, we're going 6 units in each direction. So notice that makes sense. We got 3 up here, so there's the focus. So if I knew the equation, this would be an easier way to graph this equation than trying to go over 1 and up 1/12. That would be very difficult to do. Instead, I could draw the focus in and then go make this line 4 times the focus, and I could find 2 points on the graph here and here, and it would be much easier to graph. So let's look at an example of one that we've seen before. In the past we said, or in the previous examples, we said, okay, if we go, here's the vertex at 0, 0, it's opening in the x direction, so this is a y squared, so it's x equals something times y squared. If we go +1, the first stretch we go is +1/2. So that means this has to be 1/2. But let me show you there's another way to find that same number, is I look at this distance here. This distance is also 1/2. It's the distance from the vertex to the focus So 1/2 is P. I know that A, my coefficient, is 1 divided by 4P. So A is 1 divided by 4 times 1/2, or 1/2, which is the same distance. So I have two different ways of finding that number. Now, when is it easier to find it using the stretch? It's easier to find the stretch when we have bigger values of A. When we have small values of A, like 1/12 or something like that, it's easier to use the focus and the width here. Notice the width here is 4 times P. So 4 times 4P is equal to 2, and so the width from here to here is 2. Okay, the length equals 2. All right, so that's another way to graph. And if you look at the back of your summary, parabola summary sheet, it gives you a couple more examples of using the focus to help you graph or write the equation of a graph. One more fun fact about, or a couple more fun facts about the focus of a parabola. This is a giant electric producing plant. It's a giant mirrored surface that's on the top of a mountain in the Pyrenees Mountains between France and Spain, and it gets a ton of sunlight. And all the rays come in here, reflect off this parabolic surface, and reflect to this receiver, which collects the heat energy and turns it into electricity. Well, this heat can generate up to like 3,000 degrees Fahrenheit, and it can harness the energy equivalent to the 22,000 times the energy that we get from just the sun shining on something. It concentrates it. It makes it a great deal of energy. It turns out that there is a building in London that is a large mirrored building, and it has a slight curve to it. And they found out after they built the building that sun reflecting off the building was reflecting down onto the street, and it was melting the metal on the cars that were parked below and setting some wooden buildings on fire. So they had to do some things to block that sunlight from hitting things below. So this is a very powerful generator of heat, and in this case, electricity.